turn on the recording. Okay.
Okay. Let me just find, yeah. So. Yeah, can you see it?
Yes.
Okay. So yeah, I've made these new functions. So this is to get emissions factor by scope. So like scope 1, scope 2, scope 3. And this is for the activity. So depending on like whether the level 1, 2, 3 should match and the activity UOM should also match. So those are for actually getting the factors.
Okay.
And this is for actually calculating the emissions. So there's get CO2 utility emission factor. So this is for the older format which we had, which was just using the renewable, like usage times 1 minus % of renewables.
Okay.
And this is the new one which I added in, which is get CO2 emissions factor by activity.
Okay.
So I've created this activity interface.
Okay.
So this basically it will contain what level 1, level 2, and level 3, like the descriptions, and the unit of measurement of the activity, like as in how many units of electricity you've consumed, or how many liters of some coolant you've produced, for example. And the activity is the number itself, like how many of these units have been produced. And these two are optional fields. So this is in case of those special units such as passenger kilometers and tons kilometers.
Okay.
So like tons shipped and passengers.
Okay.
And where did it go? Yeah. So you give it a factor and an activity, and based on that, it will first check if they match or not. And if ton kilometer is chosen, then you have to supply the tons. And if passenger kilometer is supplied, then you have to give the number of passengers. And based on that, it's just a simple product of the activity multiplied by the.
Okay.
Yeah, just like activity multiplied by passengers multiplied by emissions. Or in case of a normal activity, it's just activity multiplied by the factor given in the spreadsheet.
Okay.
So the way you would use this is like this, for example. So I created this activity. It's a scope 1 activity, refrigerant, Kyoto protocol, and perfluorobutane. And yeah, I'm producing 2 kilograms of this refrigerant. And I got this from one of these queries.
Sure.
So I first entered this activity and queried using this function. Yeah, so I queried using this function. I got this factor, and I took this factor and this activity and put it here. And I'm not sure if I have the output, but basically it just tells you how much is produced.
Well, can you try running it now, for example?
Yeah, I'll have to.
Because that's just a script. It doesn't depend on the chain code. Hi, Sam.
Yeah, hi. Sorry, I was in the other meeting.
Yeah, sorry about that. I think I didn't realize
Hi.
it also made a
meets.
Meets kind of a thing.
Yeah, cool. How are you guys doing?
Yeah, so it gives you the emission value and the unit of measurement along with the year. I can also provide the scope and other things.
Yeah. Okay. Yeah, that would be helpful to get the scope. Okay, this is what we need. So if you could commit that, we can start working with this.
Okay, sure.
So yeah, create a commit and pull request of this part. and then you can see about the chain code. I also have
Yeah.
some questions, but I think that about just a lot of these GitHub pull requests I want to ask you in a little bit. But first, I guess since Sam is here, I want to talk about the IPFS node, because yesterday we set that up, a public node for everybody. So I guess I want to try to deploy to it and see if we can mirror it. So let's see, what do we do? Because let's say that I have, I mean, what should we do? Would you want to you have deployed a database, right? But it's on your local node. So the question is whether I can access it from a public node, right? Because basically I need to try to pin to it from a public node, right?
Yeah.
Okay.
So I have a whole setup, like what should we be doing. So let me quickly go ahead and share my screen and get an idea, because I guess what we're trying to build here is a peer-to-peer network using IPFS, and that needs some kind of architecture. So I have something in mind just from the very top of my head. So this is a proposal. I guess you guys can see my screen.
Yes.
All right. So okay. So to get this thing working, I have a model which is working. I will give a demo in a minute. So what we need is we basically need a peer or a master node which runs the IPFS, the one just like the one that you have running. So that's the first thing. And that should also have a copy of OrbitDB, and that should be the, let's say, the original copy of the OrbitDB. That should be replicated among the other peers. And this node has an public address with a TCP and port 4001. This should be used for bootstrapping across all the other peers when we are firing the peers up, initializing them. And after a lot of checking and like a bit of like digging, I found that the firewall has to be disabled. We cannot run master node with firewall on, and that has been the cause of most of my problems for network testing. So yeah, the first thing, we set up master node. We have to keep it running all the time and bootstrap it. Other peers that will be joining this network would be bootstrapping from the master node. So the peers may be connected, peers might be disconnected, but this master node is the go-to node for all the, it's a source of truth, basically. So, and we have to enable ports, basically forward ports 4001 or 4002, which is the default ports for the IPFS, and the firewall should be disabled. That's the first thing. And OrbitDB usually communicates between the nodes using a feature called as pub/sub, which is a feature that we are enabling when we are spawning an IPFS node. So that should be enabled, and that's how they are syncing the DBs among the peers, also with the master node. So master node has the latest copy. So let's say this peer updated something, it has to always sync with the master node.
Right.
And the master node then signals the other node that, hey, this is the latest copy. Can you please go ahead and update? So that's what is basically that's a basic thing that we'll be going forward with. And the changes that I have done so far is, first of all, creating a master node over here. So under the src folder that we have master, and this is node 0. I just named it node 0, and it is responsible for spawning the central IPFS node, and also an instance for an OrbitDB that we have over here. And this DB can be used by the other parts of this project. For example, we have data upload and get data. So this too, instead of being an individual, because we have an individual set of program that was running. So I just removed it, and now I'm calling them from a controller that we have, which is always running. And this controller is in turn calling the data loader. So let me quickly show you how this all connects.
So
together.
are you saying the data loader must access through these requests rather than OrbitDB directly?
So the OrbitDB, so for example, the file that we have, that is the data loader.ts, was an independent program, because it had we are testing it using simple function call. So instead of doing that, what I did was I'm using a controller to basically call the function using the parameter, which is
as an API call.
That's correct. Yeah.
So you set up a whole API around OrbitDB rather than calling it directly.
Yeah, that's correct. So that would make the life easier, because we just have to add to this API whatever the functionality that we need. And
but then we're going to have to control who can access this API, or
because in our case only one I think one peer should be allowed to write, because all the other peers that are going to be replicating this, they won't be able to modify OrbitDB, right? They should just be able to read.
Correct. So in that case, if there's only one peer that should write, so we have the write permissions for the OrbitDB given to this central node, which is a master node. So if we change this permissions to, let's say, a star, that would mean everyone can write to this OrbitDB. But since we have the OrbitDB.id, so ID identifies this particular node
the creator of this master node, right?
That's right. Yeah. So only this central node or the master node should be able to write to the DB. So let me quickly, go through. So I have been conducting some tests extensively just to make sure that the network is functioning properly. And so I have a virtual machine running over here. And this virtual machine is a peer that is connecting to the master, and the master is running over here. So let me just quickly stop it, and I will just start it once again. So I'm just running a test over on this node, but I'm not running the actual controller for now. So this, what it does is it spins up a master node, calls this one internally, creates a master node over here. So we'll just wait for that. And once it spins up a master node, we are trying to replicate that node on the virtual machine, which is this one. So so we'll be doing that process right away. So we will come once the node is ready. We will see that there are a couple of addresses which are shared. So this is like the local address over here, because it's more of a local network that we are trying to work with. But if it is replaced by a public IP address, and we are following enabling the ports and disabling the firewall, this should be accessible by any other peers that are trying to communicate.
What about port forwarding? Wouldn't you have to set that up as well?
Yeah.
So port forwarding, I mean, for my computer to be accessible online, I did make some changes to the router, but it seems that the ISP has some firewall in place, which I cannot really override. Okay. Yeah, that's the downside. So I have reached out to my ISP, which is bad. So yeah, if we have a AWS instance or something that,
that shouldn't be a problem.
That should, we can configure it directly over there and test it out. So let me see, why are we taking this long?
Well, it's a big file, but wait, I don't know. I feel like this is a lot more than we need. So let's back up for a second here. and just go through this. So yesterday I was thinking we have this IPFS node, right? So OrbitDB writes to IPFS, but then does it give us an IPFS address? Like, for example, an IPFS hash for a file? So then if I pin it locally, can I then, if I add our public IPFS as a peer and then pin that IPFS locally, then would I be able to direct OrbitDB to access it through the IPFS hash? Like, and we can even test it. We can try to load a file onto IPFS and see if we can pin it at the public node. So, like, can we go through that a little, or is that scenario workable? Like if we try to do it that way?
I try to do it that way, yes. So I try to basically basically copy an OrbitDB which is running and store it as a file in under one of the nodes. But the thing is, OrbitDB has its own protocol internally, which is not able to recognize if we are recognize the DB as a file. So we have to use this address which OrbitDB is generating.
And what is this ZDPU A0? Is that an IPFS file? Is that an IPFS address?
Hash.
Yes,
that's correct. Yeah, that's an
so
IPFS hash.
If it can find that IPFS, can it not find its own database?
The thing is, like, if for example, if you're running on Go IPFS, which is the Go IPFS is again a version of IPFS, the same that is running on desktop IPFS. They are same, so it should not be. It seems like it's not compatible for now. OrbitDB prefers it to run from Node.js or browser to be able to discover itself.
So how about using the HTTP API? Like, then it shouldn't matter which version of IPFS you're running, right?
So the HTTP API basically helps us to connect, I guess, to, if we have a instance running, IPFS instance running, the HTTP client would help us to basically connect to that client. So for example, if you have a local desktop IPFS node that's running, so
that's what we were using until now, right? So we were connecting to a local instance through the IPFS HTTP client.
Right. So that might help, but the thing is, the replication can be a problem, because I tested it using my local instance over here that I have. And what I try to do is I try to spin up a OrbitDB using the local desktop IPFS that I have over here. And it is not able to recognize the OrbitDB that has been spun under this in a remote machine. So that's the issue that we are facing. Yeah. So maybe there's a workaround for that, but I don't know.
So
right
like,
now, yeah.
At least according to my understanding, we should be able to deploy a public IPFS node like the one Sai already has, and access it using the HTTP API, right?
So it
at
should,
least in theory, right?
At least in theory, but the thing is the HTTP port exposed? Because usually when we are exposing, for example, so the addresses would be usually the TCP and QUIC protocols that we see over here. I don't think HTTP would be exposed. So
if we would expose port 80 or 8080,
yeah, then we can. Yeah. So for example, if the port 880 is exposed, then we can try to connect using the HTTP client that we have. Yeah. But then again, would the replication be possible? That's again a different.
I think replication. So like, I think when you create an OrbitDB client, it allows you to like it gives you a call back, right? I think when it replicated or something like that, or there is an option for you to set whether or not it replicates.
So, okay. So for example, if we have, so we are creating an instance over here, which is from the IPFS that we just spawned in the IPFS node that we just spawned over here. So for replication, we have to give the OrbitDB address from what I know. Once this node is up and running, it will spit out address to us, and we should be using that address to replicate the DB. So for example, this is OrbitDB that was pre-existing, and we are able to connect to this. And it has this, again, it has its own IPFS node running on top of which it is trying to get this one. So the bottom line is, we would if we are going through this approach, which is using a Go IPFS or a desktop IPFS node, the one that we have over here, we would have to create a dependency for every peer who would be using this. Who would be using this particular project to spin up a new node. I think.
Would that really be required? Because like, can't you just take the OrbitDB address that the master node gives and like hard coded it to the project?
Yeah, you can do that, but the OrbitDB runs on top of an IPFS. So how would you spin the IPFS in that case, if not through the Java?
Through the API, like the HTTP API. Like
okay,
all the peers would connect to the
right.
master node using the API, and then use this hard-coded OrbitDB address to access that database.
Okay, so you mean to say, like, we have to use the master node's address all the time while we are trying to create a new OrbitDB instance in that case?
So I think you're using IPFS.create, right?
Yeah, that's right.
Yes, this is not an HTTP client. This is an actual IPFS instance, right?
Yeah.
Right. So in the data loader, which I had, which I'd written, I was using the HTTP API. Yeah.
Yes, IPFS client. Yeah, I went through this. Yeah, I went through this, and I do have. I did make some.
So if we use that along with, if we expose like this port, whichever, like 5001 on the master node, then we should be able to connect to that master node, right? Using this API.
Yeah, that should be possible, but my assumption was that we are trying to create different peers so that we can replicate the DB on top of that. So if we are just sticking to a single peer, which is just one node that we have, then yes, of course we can. But if you're trying to replicate the DB over over different nodes that are trying to get a copy of that, then I think we might need a peer. But if not, just
yeah, I think if we have a central node, that's okay. But I think as long as if you pin it somewhere else, then you can then use that node as your. I mean, it's the same hash. Just IPFS just replicates it on whatever node pins that hash, right? So it shouldn't. So then I think we create it on one node, we pin it on a second node, and then somebody else can then pin it on a third node, and any one of those nodes could be added as a peer for another person to pin it on their node, is my guess, right? That's how I read their architecture, and I understand maybe the nodes are supposed to be public IP addresses, or some of them are supposed to be public addresses to make it easier to discover, but isn't that, it seems like that should be it, right? And we can try it right now. I have a couple of EC2 instances.
Yeah, we can definitely. So I will just quickly, so we have a OrbitDB instance running over here.
Uh-huh.
And let me just try to, let me just close this, and I will just try to show that it's easily getting replicated in a network. So, and this should be the same if we are using your instance IPFS node that you have, and yeah, try to connect it to that one, and it should be replicable over here as well.
Okay.
Yeah. But yeah, if you're using a central node, that would solve a lot of problem, like Harsh
But then
suggested.
that also, yeah. But so I think if we do OrbitDB, like when we do OrbitDB.create instance and then pass in the IPFS HTTP client, and then in the next step we do OrbitDB.docstore. So wouldn't that step replicate the database on the master node?
No,
Like
I
off the
don't think
master
so.
node, sorry.
No, it won't replicate. It would just
like fetch it.
Yeah, it would just fetch it because we are connecting to that OrbitDB instance, and we are just okay. Yeah. So what it would do is like it would create a separate space on the master node, because the client is a master. Sorry, the server is again, it's not a client-server architecture, but in this case, the master node is a kind of a server. We are treating the master node as a kind of server. It won't be a independent IPFS node in that case.
So we would lose all the advantages of using IPFS in the first place.
Exactly. Yeah, that would be the downside because it won't be a real peer. Because yeah, OrbitDB we can connect like using the HTTP client, but we are using only one IPFS node in that case. We are not using multiple node, which the IPFS actually, it won't be decentralized. That's what we're taking away in that case. So it's a trade-off. Like we can stick to that, use a single master node, single node, and yeah, use a HTTP client for connection. But yeah, it would yeah, so yeah, it won't replicate. It's not replication. It's basically a copy on the same node that we are creating.
Another question which I had was, so do we even require like a decentralized sort of store? Because in either case, even if we create new IPFS nodes for every client, only one person is going to be able to modify that database, right? All the others are only given read permissions.
Yes.
So doesn't that make it centralized?
Yeah, in that way it is. I think but that's a general question. How decentralized is any of this stuff? We only want one source publishing it, but we want different people to have copies of it. So like one source is not the only place you could get it and serve it up. So I guess in that way it's decentralized, but it's not. I understand what you're saying. It's not the end all of just everybody being able to write to it and having different versions. I haven't quite figured this out yet in terms of a true decentralized, but I think this is better than just having a served by DynamoDB or something, which is how we did it in the first place. It was just an Amazon DB, but I think, okay, so can we go through and test this? So I have two instances. So I see what you're doing. Okay, so, but I have two instances. So Harsh, can I just run your data loader? Can I share my screen real quick?
Sure, yeah.
Okay, so share screen. So we're going to share this screen. And then we're going to share. So, okay. So this one, so this is the right data, and then you have the source data loader, right? So you are going to create a database called Hyperledger Blockchain Carbon Accounting, right?
Yeah.
And it's going to create it on this node right now, right? So I don't, what is the file that we need? I guess I don't think I have this, but I need to copy it over.
CO2 flat file.
Okay, let me see if I think I probably have it somewhere here. So let me go back to see conversion factors flat file, right? So conversion so let me just see what my instance IP address is. Okay, so okay, and then it is what, TS node, right? Data loader, source data loader .ts, just like this, or do I need anything else? Do I need to name the file?
Yes, you also need to give it load utility emissions.
Import. Okay, node utility.
Sorry.
Just a second. I'll paste in the command.
Okay.
And this is an EC2 instance.
Yes.
Cool.
So let me, in the meantime, just check to see security, all ports.
Yeah, put it in the chat.
Okay. To load utility emissions. Okay. Is it TS node?
Yeah, you have to install it. I don't think it's installed on this instance, EC2 instance.
Okay. Ubuntu install TS node. Okay, let's see how we do it.
It's just npm i-g ts node.
Just i-g.
npm i-g.
Okay, let's try that. I think I have to do an npm install here, probably.
Yeah, I guess.
Okay, so oh, it says we are at the end of the. Okay, actually, time left. Okay, I think in a few minutes I'll have to stop the meeting and then I'll send you another meeting link. Sorry, this is running a little longer, but because this is just my like free version of Zoom.
Yeah, no problem. Yeah, I think. Yeah, I think we can test it today itself, and yeah, hopefully the replication will be possible.
Okay. Okay, meanwhile.
And we also have to make sure that the ports 4001 and 402 is available for the
Yes.
for listening. Yeah.
Yes. Okay. So.
Oh, you need to run it with -- enable experimental pub sub.
Yeah.
Okay. Yeah.
I think, what is it? Enable pub sub experiment. Okay. So npm install, and then run this again. Okay, so this is here. So this is the IPFS file, right?
That's correct. Yeah.
So then I go over to my other instance. What? Yeah. Okay, I'll have to see how.
It's just sudo su.
No, it's a different thing. Sorry, 1 sec. Okay, anyway, so this is done. So actually, what was the command then? IPFS ID? Can I do IPFS?
Yeah. IPFS ID and that value, it should return. Oh no, that's a peer ID. Sorry. It won't be IPFS cat.
Yeah,
then
IPFS cat.
Yeah.
No.
All right. So it doesn't recognize. It seems OrbitDB has its own set of.
Yeah, its own hash. I believe, like, I don't think the hash is corresponding to a single IPFS file.
Yeah.
Okay. So how would so in your get data, okay, so in your get data, how does it work? You have OrbitDB service, right? And then it is you need to put that hash in, right? Is that correct? Where you loaded the data? So this gets the data. Okay, so that's correct. But then if I come to my local instance to try to get data, right? Would that work?
I guess it won't, because it's not directly visible, and the replication takes some time over the network. So if you add as a peer, if you add it as a peer, the IPFS node that's running, it should allow you. Yeah.
So enable pub sub experiment, because it didn't. And then
it gave you an error.
Yeah, but that's actually an error you can kind of ignore, because that's just a standard. Okay, so it got it. Just like Well, it got it just from this. And this is the same one, right?
So these are two separate EC2 instances?
Well, this is my computer. This is my local piece. This is my local computer.
Okay.
So I
But,
published it on
But
this.
how did it know which IPFS node to connect to?
I think that's what it's supposed to. I thought that's what it does.
So can you just quickly check the ID once again for the OrbitDB? Maybe it's referring to your local OrbitDB.
Yeah, I think so too, because that showed some 3,000 or something items, and then on EC2 you can see there's only 601 more items shown.
Yeah,
So I think
let's check that again.
Yeah.
So this is, and then CDPU.
It looks same to me.
It is the same, but is OrbitDB, is it a different database? Like, why? How could I check if the local IPFS? I mean, you're saying this is not an IPFS hash. This is an OrbitDB hash, right?
That's right. Yeah.
Okay. So is there a way to get the IP?
I'm not aware of OrbitDB provides its files, or it will be something as a QM hash. If there is some kind of OrbitDB files that can be replicated, it will be under QM hash. But I don't know OrbitDB provides such API or a function that helps us retrieve a QM hash.
Okay. So what is the best way to find out? I mean, I guess I can just reinitialize my local IPFS instance, for example, right?
So I think the best way to find out is to create, try to connect it to the client that is the IPFS, using the IPFS HTTP client, and use the OrbitDB which is running.
Okay, so how do I do that? How do you?
So we have to change the get data that we have.
Okay. Or what if I just deleted my local IPFS so that I don't have a local database? I never loaded the data on my local database, right?
Yeah,
so
that would also help. Yeah, that would also help us verify in that case.
So IPFS. So do I have to? Yeah. So. And then if I then run this get data again,